Hello, hello.
Hello. All right. Good morning, everyone. Early morning. Prayers. Posted out the lecture notes on Tuesday after the class. I was waiting for Yisun's comment, and then yesterday after you sent me when you sent me a comment, I already uh fall asleep, so I didn't reply. Yeah. Okay. So and then when I wake up today, there's like 10 comments. Yeah, he always find um my mistake. So it's very good that you can find my mistake because this proves that you have done the homework and then you know what you're doing. So see if you can find mistake in my notes or not. Okay. And one of the major thing that he found is this. Okay. So we mentioned about if you are on a curve and then the sum of the difference between the point on the curve and the focus, okay, between the two focus, if they stay constant, it is a ellipse. If their difference is a constant, then it is a hyperbola. Right? Okay. So the problem is about the A there. Where's the A? Where's the A on the equation? Okay. So this A changes depend on the shape of your ellipse. Okay. So this means the foci will pretty much determine um, which equation you use. Okay. So if the foci is horizontal, okay. So let me right. So to determine which shape, right, you really need to know the relation between the foci. Okay. So this foci is x is constant, and then this foci is y is constant. Okay. And then depend on foci, you decide which ellipse. And then after you uh, decide which ellipse, then this A will be the A. For example, this ellipse here, the A will be the A below X. And then for the vertical, what's this ellipse? Yeah, if the foci is on vertical axis, then the A will be referring to the constant below the Y. Okay, depend on what shape the A will refer to the constant below that coordinate. Yeah, make sense? Make sense or not? So if the ellipse is horizontal, okay, then the A will be the constant below X. If the ellipse is vertical, then the A will be below Y. Okay. Uh, and then if you change this A, B, right? So all the description for example, the directrix or for the asymptote will change as well. Maybe I make a summary chat for this thing so that everything store inside one slide, then you just read on that slide. Is okay? So I will add all the details in so that you just read one slide is enough. Okay. Okay. So make one slide that include all the details of ellipse and hyperbola. We are not trying to derive it. You just need to know the property. So I made one slide for this. Okay. So the other issue is pointed out by Xiangyu. Right? Who is Xiangyu? Are you? Okay. For the right guess. So Xiangyu. So so still on the point of Cartesian coordinate and polar coordinate. So one very important point is these two coordinates exist on xy plane first, right? Okay, so you start with an xy plane. There's another name for Cartesian coordinate, which is regular coordinate. The regular, rectangular. Okay, one is rectangular, one is a circle. So polar coordinate. Okay, so uh, if you notice in the textbook, right, they draw something like this. Okay, so wait. So let me write down the coordinate first, x, y, and r theta. Okay, so for both of them, you need two-dimensional. You need two-dimensional because x, y is a two-dimensional vector space. So definitely you need two independent bases, right? So in polar coordinate, the two independent bases is r theta. So the problem is, can you draw this axis out or not? Okay. So in the textbook, they draw this axis. They call it a polar axis. Yeah. So you might wonder, since you say you need two independent bases, right? So and you should have two orthogonal vector, right? Two orthogonal vector in linearly independent bases. Okay, not as maybe not necessarily orthogonal, but they must be linearly independent. Okay. So where is the other basis? Okay, how you draw the other basis? So it appear that they just need a pole and a polar axis, right? So pole, uh, pole you should think of it as the a flag, a flag. Okay, so above the flag there's a pole, right? Okay, so there's a pole, and then you got a stick below that pole. Right? The what's the English word? Malay is tiang. English is what? Pole, pole. Eh? Pole again. So pole is not the round thing. Okay, the round thing is what? Okay. Anyway, but um, so you should think of it. This pole, right? This polar axis should rotate around this pole, so that you can get all the theta, right? All the form of theta, and then this axis can grow long and short, okay, or grow negatively. Okay, so this is the r. So the polar axis grow as r, and then this polar axis can rotate. Okay, it's like the pump, right? The pump, pressure pump. Okay? The arrow can move. Make sense or not? Does it make sense? Okay. See some of you confused. Uh, okay. Yeah. Maybe later we will do one example. Let's do one example. Okay. One more question. Try sketch r square equals to cos square 2 theta. I sketch this graph here. I suggest you start by sketching r equal to cos 2 theta. Okay. So anyone have any idea how to start? Probably one of the new skill you learn in this class is sketching polar graph. So make sure you know how to sketch polar graph. So we start by sketching the graph first. Okay. So meaning I view r equal to cos 2 theta as a xy coordinate first. Okay. Because this is the most natural thing we can do. Okay. Because we know about, so we somehow view, so we view r cos 2 theta. Let me put it down. I want to put quotation mark here. First view this function as something like y equal to cos 2x as a Cartesian form. Let's put Cartesian first. Okay, because this is the one that we know how to graph. Okay, so we know how to graph y equals to cos 2x. So it's with a period 1, okay? Period half, right? So we have double the cos graph. If you don't know how to graph this, you should come and talk to me or go and do revision. So what are these points here? So this one should be a pi. Okay, here should be the pi over 2. So here should be pi over 4. And then this part will be pi. Okay, and so on. And then the last bit should be a pi. Okay. Okay. So we know how to graph this. So now the job, the other door. So the job is next job is to turn this into a xy plane. Okay. So let's be very clear here. So here is r theta plane. Okay. Here is xy plane. Okay. Let me draw xy axis first, then later I'll remove the xy axis. Okay. So let's draw an xy plane first. So I prefer xy plane because I feel more easy on xy plane. So last time, what do we did? So when we did, so so in your mind, right, there's a polar axis, which is the positive x-axis. Okay. So this control the r, and then when the r rotate around about the pole, then it will give you the theta, right? Okay. So your theta is going this way. Okay. Because the axis always start with 0. That's why this rotation here, right? So it get, so let me do some animation for you. So it gets squished into this point. Okay, so actually it's like this, right? Okay, so it gets squished into this point. That's why we have the pole. Okay, so this dimension here gets squished into this pole here. Make sense? Okay, so far okay. Okay, So this rotation here gets squished into this pole. Okay, okay. So so we start from 0. Okay, so we start from 0. 0 is at radius 1. Okay, so we have a 1. Okay. And then what do? We move to pi over 4. Right, pi over 4 is somewhere here because pi over 2 is here, which is what? Which is radius 0. So you need to move in. Okay, and then what you do next? After pi over 4, the radius grow to the negative part until pi over 2. Okay, so it is, so let me point out here. This point is minus 2 pi over 2, right? Minus 1 pi over 2. So where is, which quadrant this point stand? Which quadrant? Okay, you start from thinking all positives first. Where is 1 pi over 2? Okay. So pi over 2 is here. Okay, positive, so it's here. So negative go below. Okay, so negative go below. So you keep going down and then you stop at minus 1 pi over 2. So let me point this out, minus 1 pi over 2. Okay, right. Because this, so this angle here is less than pi over 2. So it should be on the first quadrant. But you take negative, so jump to the opposite quadrant. Okay, so you go all the way to the third quadrant. And then you continue this method. So next is 3 pi over 4. So you move to 3 pi over 4 and then you move to 0. Okay, and then you keep going. Okay. Where am I now? So I start B. So now we go from pi, sorry, yeah, all right. So we go from pi to pi, what's this? Pi, pi over 4. Pi. Hmm, did I do something stupid again? Okay, so actually, how many lines have we drawn? So we've drawn one, sorry, we've drawn 1, 2, 3. So we only draw 3. So we are going from 1, 2, 3. So we're going to draw this line now. Okay, so here is 1 grow to, sorry, 0 grow to 1. Okay, so we start from 0. 0 at where? At 3 pi over 4. Okay, 3 pi over 4. So to be precise, right? So let me draw every angle out. So here is a pi over 4. Maybe here is a 3 pi 4. Okay, so you grow along 3 pi over 4 until you reach 1 at the, is the 1 pi. Okay, and then you go from 1 back to 0, but this angle is over pi. Okay, over pi and positive, right? So it is exactly following this path here. Okay, and then you keep going. So what's next? Next, you should continue like this, and then it's okay. If you can't follow it, please see me today. I got office hour. Tomorrow I also got office hour. Okay. If you want to talk about detailed stuff, or if you want to talk about something you missed in the class, you come and talk to me. Okay. or you want to discuss tutorial stuff also can. All right. So this is the r equals to cos 2 theta. Okay. So if you prefer, you don't want to draw this xy axis here, right? Okay. Usually I put xy axis here. You can draw the polar axis, so you can remove this line. Okay. So you just left with the polar axis. Okay. So there are a few ways to see this. Although you are using polar axis, I want you to remember that you are still on the xy plane. Okay. Okay. But the end question is r squared equals to cos square 2 theta. So how to draw this? Right. Okay. So one way to see this is if your point need to satisfy r square equals to cos square 2 theta. So this means r is equal to square root cos 2 theta. Okay. So this places a restriction on your curve. Okay. So meaning that inside square root you cannot have what other square. Oh, cancel out the square. Okay, yeah. Okay. Oh yeah, right. So, yeah, let me see what's going on here. Oh, okay. Sorry, I start with the wrong question. So this one is very weird. So I should put a square here. Okay. So the point I want to talk about is this one. So, um, uh, yeah. So actually, we want to plot r square equals to cos 2 theta instead of cos square 2 theta. So now we got a square root here. Okay. So, uh, so inside the square root cannot be negative, right? Okay, so this will throw out some of the angle. Okay, in particular, what angle we throw out? Uh, Pi over 4 over 4. So in particular, we throw out these two angles here. Right? Okay. So we throw out these two angles here. So what's this two angle actually? So here is what? Here is 3 pi over x. So we throw out these two angles here. So these two part correspond to where? Left part. You mean this part? Pi over 2 is here, right? Yeah. Oh, what do you mean left part? You mean this part gone? No, I mean this part left hand. This. You mean this part gone? Not exactly. Not exactly. Uh, yeah, not exactly. So, um, so theta here cannot be pi over. So what? No. Okay. So here meaning that pi cannot be what? When is pi negative? Pi cannot be over 2 and 3. Okay. What? No. What? No. To be what? Ah, interval. Uh-huh. Oh, right. You are right. So you don't want this whole part here, right? Okay. This part is -1, but this part is also a negative number. Okay. So you don't want everything in between. So should be around 1. In between pi over 4 up to yep, 7. No, not 3 power 2. I think it's 7 power 4. Okay, so this means, okay, let me label the part that we don't want. So we don't want this part and this part, right? Because if we fit this y value into this, right, we'll get square root negative something. Okay, so we don't want this circle here. So this part here exactly correspond to the top and the bottom leaf. Okay, so we need to remove this leaf here. Okay, so we will start with the basic curve, and then we remove the top leaf and the bottom leaf. So this one is for r equals to cos 2 theta. This one is for r square equals to cos 2. Okay, is that okay? How about the rest? How about the rest? Okay. But so far you want to break. Okay. Yeah. Okay. Also one thing you can see that if I replace theta with negative theta, right? So there are some symmetry you can see from these two curves. So if I replace theta by minus theta, okay, I still get the same same one, same shape. Okay. In particular, there's a symmetry along this polar axis. Right? So if I change theta to minus theta and the graph stay the same, there's a symmetry along the polar axis. Okay, make sense? Okay. Okay, maybe I talk about other stuff next time. So today I talk about polar axis, symmetry here. Okay. Any question so far? Yeah. Hmm. Ah, yeah, right. I just read I missed the 2. Hmm. Uh-huh. Why doesn't the R change? 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 Oh, I mean, why doesn't the R change? Okay, so let's determine where the R, right? So what's you want to ask about the codomain of R, right? The image of R, image of R. Yeah. So let's examine what's the image of R. Okay. So cos theta bound by 1 and minus 1. Okay. Right. So uh so what? So um so not exactly. Actually, we can do better. It is whether equal to cos 2 theta less than equal to 1. Okay, right? Because we already removed the bottom part. Okay, so we can do better. Actually, cos 2 theta is bound by 0 and 1. Okay. So if r square equals to anything between, how should I say? How should I say? Can I say? How should I say properly? So, okay. So r square. That means r square is bound by 0 and 1. Okay. So if you take square root, you still in between 0 and 1. Does it sound better? Okay. Anyway, I think we should stop at this stage, right? But if you want to plot, you still need to go to r. Okay. Never mind. So anyway, because cos 2 theta is bound by 0 and 1, so r square is bound by 0 and 1, and r is also bound by 0 and 1. Make sense? Yeah. Hmm. Will it change? Where do you think it changes? Hmm. But I mean, you still achieve all those points in between. Yeah, yeah, yeah. But of course, it's not the exact same point anymore, but you still achieve those points because our real line is very, uh, we say it's complete. So everything in between we still have point. So we have enough point to fill those in. Yeah, yeah, yeah. So this is a special property of our real number. Yeah, yeah. Mm. Okay. Yeah. So somehow, yeah, yeah, you are right that somehow that curve, mm, the curve changed, but you still get the whole curve. I can't say the curve changed. I should say the parametrization of the curve changed. If you get what I mean. The parametrization of the curve changed. But anyway, for the rest, this is enough. Okay. So this tell you that what's the domain of our R. Polymer. Yeah. Where's the image of our R? Okay. Any other question? Other question? Any other question? If you look, yeah, try work out yourself at home as well. Graph this graph, whether you can graph it or not. Mm. Thank you. Okay. Okay. Luckily, we got a new good news for this problem here. Last time I said I solved this integral using computer, right? So Liang Jiangyu suggests a change of variable, and then I managed to work out. His step is a bit there's some issue with the step, so I work out myself using this change of variable, and then use some reduction formula, and then we managed to get the same 9/2 answer, 9/2 pi. Okay. If you have time, you want to play around with the integral, you can try, but otherwise we have solved this question actually in 3 ways. Okay, so the first way is using polar graph. The second way is using XY graph. The third way is using the parameterized curve. Okay, we have tried 3 ways to show that this, I mean, try by you. So you try that 3 ways to find the area of this curve. Okay, yeah, so we provide 3 ways. So the first way we did in the lecture is the um, polar graph. The second way we try is the XY graph. And then the third way, I didn't show it here, is done by Jinghua. So, and also I think the other person is, yeah, Hongyu also try it. So using the parameterized curve. Okay, so that we already tried 3 ways to find this area here. Okay, all right. Actually, I wanted to show another example. maybe just let you see. If you want, you can plot at home. So this one is asked by Sui Long. Okay, so Sui Long asked me how to plot this graph here. Okay, this is taken from Adam books. Is it Adam? Adam or Stewart? Adam? Stewart? Adam, okay. Adam books. So r equals to 1 theta. How you plot it on xy plane? Okay. So r equals to 1 over theta is quite familiar to us if we see it as a y equals to 1 over x. Okay. So this is the on r theta plane, it is this graph here. So how we translate it into xy plane? Okay. So this is kind of tricky. Okay. What do I mean tricky? Because at theta equals 0, this thing will shoot to infinity. Right? When theta is equal to 0, this number will shoot to infinity. Okay, so how should we do it? So, so we need to check the limit. Okay, everything in this cost line, right? So if you meet something that will go to infinity, or go to infinity, you need to check local behavior. Okay, meaning you need to start from something finite and then look at what happened when I go close to that infinity point. Okay, so in this case here, we look at the y value starting from theta that is positive. Okay, because we know that here something go wrong. Okay, but we know what happened here. So we start from what we know, and then we take limit up to the 0 point. Okay, so this is what I'm doing here. So using the change of variable between polar coordinate and xy coordinate, y is equal to r sine theta. Okay, and then r is defined by this function here. So I can sum it in, and then I look at this limit here. So this limit you have to know sine over theta over theta, sine theta over theta get very close to each other when theta is 0. So this means that when the sine graph depart from 0, it is actually very close to the y equal to x. Okay, so this is the what this limit doing. Otherwise, you can use L'Hopital rule to show. So I put an I here. Okay, so it's actually 1. So that means if you approach your angle from the positive side, okay, this your y is actually approaching 1. So for this point here, it's actually 1. Okay, so that's why you got this asymptote coming out. Okay, so when the angle approaching 0, okay, your radius is approaching 1. Make sense or not? Make sense? Does everyone know how to say? Don't look at this part first. Don't look at this part first. Okay. So we look at the angle maybe from pi over 2. Okay. So you see, pi over 2 is 2 over pi. Okay. So when pi over 2, it is 2 over pi here. Okay. And when the angle start getting to 0, okay, the point achieve 1, not achieve 1, approaching 1. So you get increasing point approaching 1. Make sense? Make sense? Okay, so how do I get this spiral thing here? Okay, how do I get this spiral thing? So now we look at this spiral thing here. So you can see that when the angle keep increasing, the radius keep decreasing. Okay, so when the angle increase, the radius decrease. Increase, decrease, increase, decrease, increase, decrease, increase, decrease, increase, decrease. Okay, and then you keep going on this endlessly. So that means it is infinitely spiral into the origin. Never stop. Okay, so you can think of the water flow inside the sink. Okay, yeah, make sense? Yeah, yeah. This question is a bit tricky and quite hard. There's a and then there's a further question: is they change this graph to something like this, and you find the asymptote, and then the answer is given by this. Yeah, you can try out to find this. I haven't tried. Yeah, but you can try and graph this thing out and then see how it looks. Okay. Yeah, I think this is by so far is the hardest one. Okay. Any question? Any question? Okay, I let you ask questions. So after the question, then we will take a break because any question? Stupid question also. Why this course so hard? I think every course is as hard. Math course is like this one. So you need to try enough example. If you can't see what I say, right, you need to try enough examples. They actually I met some student, right? They just listen to what I say and then they try a few examples, then they are quite good. So this depend on people. So if you are the people that you need to work hard, do exercises, then you do. If you are the people that I get the concept, I get some example, I can do it, then good. So this really depend on people. And I give you all the resources you should try if you need. If you don't need, never mind. But if you need, you definitely need to try. Okay, don't be lazy. Okay, just do what you need to do, then that will be good. Okay, for example, Xiangyu, right? Quite rigorous. Yeah, you try to be rigorous, and I suggest you come to maths degree. We will do very rigorously then. Okay. Any last question? Last question? No? Know how to graph already? Um, any question? No? No. For this course, no. Yeah. Actually, maths, I'm teaching another math degree one. We did some proof. Yeah, we did some proof there. They have assignment. Assignment also have some proof question. But for you, you have to know how to graph, okay, how to compute, how to do integral, so on. Okay, how to use the formula. Okay. So if you found some interesting question, right, you can send to me and then we can do it. And if it is helpful, then I'll show it from here. Okay. No more. And one more thing I want to say is mistake is very important. So learn from mistake. Okay. Because sometimes we do research, right? Don't have mistake, then feel like don't know what's happening. If you have mistake, then you know here B, here is A, B have to put a minus, A have to put a minus. And these all these small things, right, will make up the whole theory. So it's very important. Mistake. Learn from mistake. Always learn from mistake. Mistake is not horrible. It's very good. You need to learn from the mistake. If you make mistake, then very good. Then you need to learn from it. Okay. If no problem, let's break until 8:55. Then we will start the today's lecture. I mean. Ah,
Right，
yeah.
如果我到这里，我之前是没有做哈法，因为这课是来 s 没听的。之前我到这里话，如果我用 x y 来 sub 的时候，因为我是从0 to 2派嘛，所以它的 x 会变成2 to x 会变成0。如果我没有放，
所以你要从哪里去哪里？你要 integration 哪里到哪里？
因为我是从这里到这里，这里到这里，然后我就乘2那个。
对，然后你讲你不要做这个的吗？
我有想到来这是什么确认啊？我要做like 0 to 2派，
可以啊。
不过我也要做 substitution，因为 substitution 的话，like 如果我放，因为
2和
在
2派咯。
theta 是 like 如果那个 angle 是 like 一样的，那个是 like 0，拿到的那个
是零，
保留也是一样，就
也是一样。哦，对，当你在做这个 substitution，不是你其实要 make sure 你的那个 domain 不是 over 那个 domain 不是那个 sign 其实是 injective 的，所以如果你从零到2排，可能就有这个问题了，你就不 injective 了哦，就像你讲的，他可能会拿到一样的号码还是不一样？
一样。
一样，所以 that's why 他们就要靠这个 symmetry 啊，去掉这个问题哦，懂什么意思吗？所以每一次你在做那个 change substitution 的时候，其实你要 make sure 你的 domain 是在那个 injective range 里面。所以比如说那个 sign 啊，sign 是这样的，所以你看 sign 的话，哪里是它的 injective range？injective 就是说你你就是说你 injective 就是比如说你看这两个 map 去同一个点，这样你等一下要送回来，你要送去哪一个点呢？你不知道不 injective 哦，所以 injective 的话可能
不是一样的点的，
就每一个点都有对应回
有那个
对一个 unit 的那个 data，所以应该是他要选这里吧，所以你要去掉这个点，去掉这个点，然后你就拿这一圈，所以零只有一个会去零吧，然后减一也只有一个会去减一吧，这个是必要的，没错。所以我们的 range 应该是活在这个减派over 2到派over 2之间，可以明白吗？OK，如果你选0到2派啊，这样如果我 S 等于0的时候，我要送去这个点，还是送去这个点？不知道。但是如果我选这个 range 的话，然后我又丢掉这个前面跟后面的话，这样0就一定要送去这里。啊，
0跟2派也是可以。
如果我 square 它的 R 的位置找回来，但是我这个 angle 吧，它本来在这里 square 不会来这里。
对，可能它的形状会比较缩一点还是怎样，所以我就对，是这样，但是你是可以 build 到完的，我是说我的意思，
就一样的这样子啊。
对，shape 是一样的，它只是比较
扁一点子，
扁一点。
是应该大一点吧，因为它小于开放之后变大了。
它应该是一个部分，我想想，
它小于的话，它2开放是变大。
小对吗？开放，OK，开放，OK，呀，它对，所以它是因为它要 square root，对，不是 square，如果 square 的话是变小，square root 就变大了，
可以点，
小于是变大，大于是变小。
因为如果 square 的话是变小，square root 就变大了，
开一杠哦，
0.000的话变大那个。
但是我们现在是 square 就变小，square，你好了吗？OK，
就这道题，我去做过，它最终就是积分的时候，就是它是要有一定技巧，然后又比如说分子分子同时乘以根号下1.3其他这种，那么如果说考试的时候，就是你不写那个过程，只用计算器算出来，会不会给分？
不可以，你有什么计算机这么厉害可以算出来？
没有，就是定积分它是可以算的，计算器可以算定积分，
应该不可以带那种计算机进来。
没有，那不是函数型，不是
graphic 的 calculator，
那个不是，它那个不能编程，它那个不能 programming 的。
没有，我不是说 programming，是可以画 graph，
不能画 graph，只能算定积分。
可是我们的 scientific calculator 应该算不出 integral，
算出哈，那个
你会按它？有方法的按。
integral
是哈，我没有 try。
可是 radian 的话就不一定，
因为它只能算那种定积分，不定积分算不了。
OK，但是应该是不可以啦，应该是不可以。
但是它的技巧真的太高，它要分子分子同时乘以根号下1.3，但是其他那种就是
对，给我看看，是这边吗？你有我做的吗？还是都有做在这里
homework？
你说这
下面不是负面题
应该没有在这里，你有没有我做的？这个是他早上问我，看看。
一开始我没看他怎么解，然后看个教材上有解吧，他说要么用那个软件解，然后就是
调到软件，
或者用分成同乘以1.3，根号下1.3。
这个哈，
对对，
没有什么特别吧？我觉得你是说这一个哈，你说这个要用这个 sign 哈，
就是它这个有点技巧，我感觉
这个没有什么太大劲，这个 conjugate 罢了，这 conjugate
就是你就是
你怎么想出来哈？
就像你
要想出来，没有你要想这个东西出来的话，要想这个东西出来，是因为你看 sign，我们通常比较喜欢 sign。
对，那你用解定就是 calculus one 那 chapter
对，
没有一种方法好像提到就是这样解。
不能啊，全世界有这么多种方法，怎么跟你讲到完？有时候就是要从有的东西变出来嘛，对不对？但是问题是
又有点技巧，
对，但是应该没有太大的问题吧？
就直接说
最多一个
有
conjugate
时候考试的时候就是就是如果说做到这里，然后只按计算器出答案会不会给分？
应该就不会拿到满分咯，
不会拿到满分。
我不知道有没有1点分啊？
我们上学好像就是期末考试时候好像没有这么刁钻，
有这么刁钻的？
没有这么刁钻，对，都是就是那种通法能解，不是说这种根本就不是很自然，我感觉。
因为2排是他说会遇到那个问题
啊，对，就是那个遇到问题哦，它就是要分成 symmetric，然后要用
这种
缩短它的，
可是你也不能
这种可能就是背结论，
也不能用零，
不要背，
也不能用
要变通一点
排到排
啊，
也是不能。
什么在
你刚刚讲的那个 example，
我说
你刚才是讲0到2排嘛，然后你讲的是 negative 2排到0，还是negative 派5到派5？
我要缩短那个 domain。
有一个东西是来这样子的，
啊，对，
但是也不能用，因为这个点到这个点
都是0啊。哦，
所以你现在只能用的方法就乘2个那个
乘2，然后是从 negative 排到
跟着那个 symmetric line 那边的。
你要从
那个排了，不是，
negative 排不2到 negative 排不2到排。
哎呀，那个排
啊，这样的话就是减1跟1哦，那就不一样哦。
比如说这个单词没变，OK 啊，不要背，变成
但这种题目肯定只能靠背，因为我这东西
不要背，你背不完的，我跟你讲，太多东西啊，
这种肯定是背得完，因为这种有技巧的这种题肯定有些人，因为
真的你会到一个程度你背不了，你相信我。
但是我本身就不是主修数学，这种
没有，我明这个是思维方式，对，
但是你这种方法
不用主修数学，这个主修生活就可以了。
我知道，
对，
这种方法你肯定要靠积累，你这种
你先记，你可以先记，但是不要纯记。
我知道，就是
OK，
大家知道就是为什么他能想到这个，但是你一开始
对，
是做这种题的时候，基本
对，不要纯记就这样，不要纯记 ，OK，不要纯记，
谢谢老师，
对，没事。很固执哦，你东西。
快了，我有个问题
OK，来，
就是
最后一个，
刚才你那个 r 等于cos20塔，然后你把它想把它画成那个 r 平方等于cos20塔，它的形状应该会变的。
OK，会，好像是比较肥一点，但是我觉得比较肥一点，
就不能只把上面和下面给它削掉。
OK，可以这样讲，但是我这个只是 sketch 吧。对，因为我们也不是很准，它的形状是一样的，
形状不是一样的，
形状是一样，它只是变比较，
对，大概一样的。
对，
这样会
sketch 嘛。OK，我等下再说一下，如果你们要这么准的话是可以的。OK，
我不知道问他
OK，最后
刚才讲这个你要讲是不是因为那你剪了它也是 reflection 这边说也不用平和讲。
觉得可以这样理解，
对，
我还没有 check 过，但是听起来感觉是很对，感觉很对，感觉很对。你 check 了吗？
没有，
你写出来，你写出来那个 point，我觉得是对的，你写出来吧。我觉得对的，
说他那个一样的，
我觉得对，
我直接打一样的，
我觉得对呀。
对，我去
写出来什么？我觉得是对的。
就是他 suppose 现在 square root 它是加减的，在
其实它就是对
Okay. Okay. Yeah, okay. Start 啊。
你在搞呢？
改了，我改了，你再 check 一下，我改了，全部改了，你再 check。Okay. Okay. I think it's very good. I think some of you are very super detailed. Okay, super detailed. So for this graph, right, I'm just sketching. Okay, so this is still following the question from Xiang Yu, right? Okay, so although you still get these two rows, okay, if you take square root, supposedly, I guess this leaf will get maybe a bit fatter, okay, wider a bit, okay, get wider a bit. Okay. But this is just a sketch, so the general shape should be the same. Okay. If another question, if you say, hey, maybe I have a plus minus sign, okay, here, right? Another question is plus minus sign. So I suggest you to check whether this plus minus sign is it correspond to opposite. Okay, so maybe plus is here, then negative will go here. So this means if you take 0 to 2 pi, you are looping this twice, I guess. Welcome you to check. Okay, try and check. Okay. If you take negative, you still leave on one of the leaves. Okay, go and check. Try and check. Okay. Right. All right. You try and check. Check. My claim is you loop this leaf twice. Okay. So because you ask, hey, these two leaves gone, where they appear, like where they disappear to. Actually, they don't disappear. They become the same two leaves here. Hmm? Ah. Ah. Mm. Mm, mm, mm. No, 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 no. The point here is you need to find all the R that satisfy this number here. So you need to consider plus minus. For example, just no need to look at this. So just solve s squared equals to 1. So there are two solutions to it, 1 and minus 1. So both 1 and minus 1 satisfy s squared equals to 1. This is the sure. We can discuss after the class. Okay. Okay. So next. Okay, so we should start new stuff today. We start. Let me check where should we start. Last time we didn't talk about this question here. Do you guys try out or haven't tried? Or have you tried yourself? This is the last bit when we introduce cross product. Okay, if not, then I just quickly run through these two examples here. So we know that cross product we can use to find the normal vector. Okay, we can use to check. There's a formula to find the theta between A and B using cross product, similar to the dot product. Okay, so here, actually, you also can use cross product to compute the parallelogram built up by A and B. Okay, if you compute the length of A cross B, remember that A cross B has a vector coming up the plane, but actually, that the length of that vector, right, is the area of the parallelogram that make up by A and B. Okay, so how are we going to show this? So do you know what's the formula for parallelogram? The 1/2. Just given the length of A times length of B equals to sine theta. So just take the perpendicular height multiplied by the base length. Okay, so this is exactly the formula for cross product. Okay, there's nothing special here. Another thing is this triangle. Okay, this triangle here. So, okay, one thing I will still want to advise you, don't try to memorize things in mathematics. Okay, this won't help you. Okay, maybe you will think that it's like eating pill. You think eating pill is very fast to recover, but please don't do that. You can, how to say? No. For fast relief, you need to take pill, but for long-term remedy, you don't take pill. Okay, fast relief, you take pill, but long-term, you should identify why you get fever. Okay, but when you get fever, please eat Panadol. But you still need to identify why you get fever. Then in future, then you will avoid. Okay, so I mean, yeah. Okay. Okay. So important thing in mathematics is understand. If you understand one thing, then you can apply to most of the thing. Okay. Want to find this area here. Okay. So how to do? So you should plot. Give you some idea. You should plot this PQR first. Okay. You plot PQR. I don't know what is their relative relative position, but let's say we assume this is the relative position. So you form a triangle here. Okay. If you multiply them out, actually you get a parallelogram. Right? If you multiply it out, reflect, okay, you get a parallelogram. But you know how to compute area of parallelogram, right? From the previous question. So this is just half of that area. Okay, so I'll let you try this at home. Okay or not? Get the idea? If you can't get the idea, I can repeat again. Anyone can't get the idea? So you start with a triangle, and then you can multiply out the triangle where you get a parallelogram, and then you know how to compute the parallelogram, or just divide by 2. Okay. Yep. So try compute and then check with my answer later. All right. So let's start with the new stuff. So this is interesting stuff. Equation of lines and plane. Okay. So equation of lines and plane. So talk about line first. Okay. So how do you make a line? Idea, actually, we talk about it when we talk about polar coordinate. How to make a line? What do you need? What do you need to make out a line? What do you need to make out a line? Equation. No. I mean, physically. Okay. 2 points. Okay, good. 2 points. What? I didn't hear. Sorry, I didn't hear. So you need 2 points. Good. So you need 2 points. Okay? Yeah, you need 2 points. Okay. 2 points, and then you join them up together. Okay. So this is actually kind of more work. I can do safer work. Okay. I have more economics work. So I can just take 1 point and then make 1 line. Okay. Then I will reach your point as well. Okay. So I just need 1 line for 1 vector plus a point. So this is more economic. Okay. So next, so the idea here is a line is determined by a fixed point and a fixed direction of vector. So the set of all points such that the vector P0 to P is equals to TV for some real number T. So this TV should remind you of the solution to homogeneous system of linear equation. So a homogeneous system of equation, if you have some non-trivial solution, your null space must be a subspace. Okay, so you are either a point, 0 subspace, a line, 1-dimensional subspace, a plane two-dimensional subspace. Okay, so today we talk about one-dimensional subspace and two-dimensional subspace. So you will see something very similar here. So T times some vector. Okay, remind you of that form. Okay, example. Okay. Okay. So you will see similar stuff here. So if so you can translate your point by R naught. Okay. Translate your point. If your line doesn't start with the origin, doesn't touch the origin, doesn't start with origin, then you need to translate it. Doesn't have origin as the point, you need to translate it. So if I'm not wrong, you should think about something like this. When t equals 0, r0 is 0, so that means here, if I'm not wrong, try and check. Okay, so you translate the line with r0. What else? Okay, so because we only interested in 3D for this course, so you can write everything, every point explicitly as vector of 3-dimensional. Okay, so if you write out this vector, this equality will hold for every component. Okay, that's all. There's nothing special here. Does everyone see it? Or should I write it as a vector form first? So write it as a more familiar form. I think it's this one. So let's write it in a more familiar form. At least for me, this one is more familiar. I picked this notation is actually because of, I think, history. Because these people work from different area. So one way you work from calculus, the other way you work from algebra. And then somehow they see that they meet, the theory meet. Yeah. So this group of people use this notation, that group of people use that notation. That's why I think they somehow differ. Okay, so okay. So these are just mentioning the parametric. So okay, so this equation here, right? Okay. So in the last week we just learned about 2, right? Now today we learn about 3. Okay, so we add one more dimension, 3 parametric equation. Last time we only have 2, right? Now we have 3. Okay. So these are also called the parametric equation. So after 1 week, you go out a level. Okay, you go to R3 now. Okay, so let's think about this question here. Find a parametric equation of the line that passing through the 2 points. Okay. Yeah, so this question is, we can use this example to tell you what is to memorize, what not to memorize here. So if I show you the step, it is easy to memorize. So you see the line, then you just build the equation using my method. But if you want to use concept to solve this question, so you need to start from line. Okay. So what is line? This time and a vector. Very good. So you need to find these 2 things. Okay. So how many points you have now? 2 points. Good. So you just need one of them. How about vectors? How to find vectors? How to find vectors? How to find vectors? Vectors that connect these 2 points. How? Okay. Sure. Let us take a step back. I'll take a step back. Okay, let's name this point as 3 minus 2, 4. B is equal to 5, 6 minus 2. Okay, so just sketching. Let's call this A. Let's call this B. Because this is a 3D, so this is just a rough sketch.
on a 2D plane in 3D. Okay, so don't be fooled by this picture here. Okay, so how to find vector between A and B? Minus, yes, minus. Okay, minus, good. So minus. So how to minus? Okay, B minus A or A minus B. Sure, never mind, both can. Maybe pick one. Let's see. Pick B minus A then. Okay, so to be precise, right? To be precise, A is a point, B is a point. Okay, so we need to give name to the vector. So what name should we give? Can we give? We will give a OA and a OB name. We give O because here is origin. Okay, so it makes sense to give OB and OA so that this notation will fix. So we will compute what is BA, which is OB minus OA. Huh? Is it? Okay, then I want to compute AB. I want to compute AB. So OB minus OA. Okay, OB minus OA. Okay, good. Okay, minus OA. Okay, so what do we get? What do we get? 2, 8, and -6. Okay, good. So it goes to 2, 8, -6. Okay, so now we got a line and a point. How should we make out the equation? How do we make out the equation? Any idea? So the line, so let me write here. The line is TV. Okay, so it's T times AB in our case, which is T times the column vector. Okay, but this line here contain origin. Okay, so we need to make it contain either A or B. Okay, so let's make it contain A. Okay, so the parametric equation we want to consider is, so L is equals to A plus TV, which is equal to okay. Is it confusing if I keep changing notation here, or you guys can swap between this notation? Can swap? Okay. So swap between notation, but you don't combine column and vector together, right? So if you use column in one sentence, you use column. If you use row in one sentence, you use row. Okay. Okay, maybe don't combine in one question also. So just try to be consistent. In one single question, you just use the same convention. Fix your convention. Okay, and then you should check that actually 5, 6 minus 2 also in this line. So I ask you to check if B is in. Okay, and other thing you can do is, let's say if I change this to B or not, B, does it work? Yeah, you change, try. They all should work. Okay, so this is exactly what we mentioned at the first, before we start the line. We have 2 points joining a line. We have 2 points joining a line. 2 points joining a, yes, 2 points joining a line. And then now we just use 1 point and 1 line to make our line equation. Okay. Right. Okay. So next, how to check B is in L. So you let your L, you let your XYZ equal to B, and then you find T. Yeah. You can do row reduction if you want. Yeah. Okay. I think this one is very good question, because every time we need to somehow make sure some point is whether it's in the plane or not, whether it's in the line or not, whether it's in something else or not. You need to sub your point into that
equation as a solution. Okay. Next is a symmetric equation. So because you can see that in line, right, there's a common variable. Okay, there's a common variable t. So you have common variable t, for example, plus at y equals to y naught plus bt z equals to z naught plus ct. Okay, so you have these common variable here. Okay, so this is coming from b plus, sorry, I think what should we use better? Maybe we use a w plus ev. Okay, so I should put this together. So there's a common variable t here, so you can move one side. Okay. Then you need to make sure that these terms agree because they have the same variable. This symmetry equation will come in handy later when you're doing some other question. Okay. So let's see example how to use this. Okay. So this is the same. Is it the same? Yeah, this is the same curve that we have, right? Is it? Is it, or is it different? Actually, it's different. Find the symmetric equation of the line that is parallel to the vector 4, -3, 2, and passing through 2, 5, -1. So this question is very good. They give you the thing you want, 1 point and 1 vector. Okay, so how you write out the line equation? So you have a point and the line equation. Okay, so you might wonder how we can always do this, right? Because if you sub t equals 0, then this is the solution you want. Okay, so we are a bit cheating here. So we know that t equals 0 is one of the solutions. So we make the t equals 0 solution to be the point we want. Okay, so this is the cheat we play here. Okay, so we can straight away give this. So now we want to get the symmetric equation, right? So any idea how to do this? Okay, so from here you can get 3 equations, right? Okay, so you get x equals to 2 plus 4t, y equals to 5 minus 3t, and then z equals to -1 plus 2t. Okay, so first t equals to x minus 2, so t equals to x minus 2 over 4, and then equal to y minus 5 over minus 3 equals to z plus 1 over 2. So you find the t in terms of x, in terms of y, in terms of z. Okay, so when you do fast, right, you should ignore this part already, okay, and then see how you go from these 2 points to this equation. Okay, so you can see that the things beside x, right, okay, is coming from the point that you have. Okay, so you take x minus 2, y minus 5, and z plus 1. But why there's a differ in the sign here? Why there's a differ in the sign here? Because you want this point as a solution to this formula. Okay, so there's a differ of sign here. And then the vector here will become the denominator. Okay, so can I back out a bit? Yeah, so let me back out a bit. So let me back out a bit here. So this says that the vector this is a line with vector ABC
passing the point naught, y naught, and z naught. Okay, so you should know how you go between them and also know directly, given these two information, how to get this equation. Okay, both things you need to know. Yeah. Okay. So remember there's a sign here, sign change here, because you need to make this point as a solution to this equation. Okay. For the derivation is this bottom part here. This is the derivation. And then this is the thing you need to know. Okay. So part B, at what point does this line intersect xy plane? Okay, so when you intersect xy plane, what does it mean? Z is equal to 0. Okay, so this, when you set z equals 0, right? Okay, so what happened? So this shows this how useful is this symmetric equation, because when you have condition on one of them, then you have effect on the rest. So if you set z equals 0, you get half. Okay, so you need to solve these two equations here. So when is it? X minus 2 over 4 equals to half, and y minus 5 over minus 3 equals to half. So this implies that x equals to 12, y equals to 7 over 2. Okay, so you get that the point is 4, 7 over 2, 0. Okay. So note that when we put point, right, we put curly round bracket, okay? We put round bracket. When we see the point as a vector, we put what bracket? What's the bracket called? Forgot what's the bracket called? The arrow, the sharp. I don't know what's the arrow called. So if we regard this as a vector, okay, if we regard this as a vector, we change it to the other bracket, okay? Or we can use the square bracket for the column vector. Okay. So there's some subtlety here, so you need to take note. Sometimes it's round, sometimes it's square, sometimes it's an arrow bracket. With an arrow bracket. Okay. Will we try one more? Familiar ourselves. So find the parametric equation of the line through 1, minus 2, 3 that is perpendicular to both x axis and the line. Okay, so what does this mean? So let's draw out what this question trying to ask. So you want to find equation of line, okay? They give you a point, good. You give me a point, I still need a vector. So what's that vector? That vector is perpendicular to both x-axis and some special line, okay? So what's the line that perpendicular to two lines? In 3D, huh? But let's call this line L. Okay, this is 3D. Remember, now you're living in 3D now. Okay, so what's the vector that perpendicular to both x-axis and the line L? Yeah, orthogonal. So how to get that vector? Cross product, good. Okay, so you consider the plane spanned by this two line, and then you take the cross product. Then you will get a vector coming up. Okay, that is orthogonal to both of these. Okay. Where am I? Okay. So now we need to consider the cross product. So cross what? So x-axis is what? So you need to cross two vector in these two lines. So in x-axis, what vector you want to pick? 0, 0, x. From where is it? X, Y, Z. 1, 0, 0, 0. 1, 0, 0. Okay, 1, 0, 0. So you just pick anyone in x-axis. 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0. Never mind. Because we care about direction only. So we just pick one. So pick one vector from x-axis, which is the easiest one will be 1, 0, 0, right? Easier to calculate. Okay, so how about the line? What vector you can pick from the line? What's the vector of this line? Just now we learned that this is the point that it intersects, right? The bottom is the direction vector. Okay, so the vector, can I say vector? The vector of L is 2, -1, and 5. Okay, remember? So the top part is the point it intersects, the bottom part is the vector of that line. Okay, so now you cross these two together. So this is the direction vector you need. Zero, zero, 2, -1, 5. Okay, so anyone try compute what is this 2? Okay, if you compute it, I think it's 0, -5, and -1. Okay, so we got direction vector. We also got a point 1, -2, 3. Okay, so we need to fit these two together. So now they ask for parametric equation instead of symmetric equation. So what's the parametric equation? So we got a point, we got a vector now. So we just take x equals to 1 plus 0 times t, y equals to -2 minus 5t, z equals to 3 minus 1t, which is minus t. So why? Remember the cheat we use here is because we make the solution for the point to be t equal to 0. Okay, so this is the cheat we use here. So that's why we can straight away build this parametric equation. Okay. So we make t equals 0. When t equals 0, it is exactly this point here. So this line will satisfy the condition that it has this vector and also passing through 1, -2, 3. We make it pass when t equals 0. Make sense? Okay. Okay. So similarly, you can turn this into the symmetric equation. Okay. So let's do exercise. Turn this to symmetric equation. So if we turn this to symmetric equation, we will get x minus 1 equals to 1 plus 2 over minus 5 equals to z minus 3 over minus 1. So you can see that the top part here is something to do with the point, and then the bottom part here is something to do with the actually we cannot do this for, sorry, we cannot do this for this case. So this one have to be split. Going to be split. Okay. So this is a special case. Okay, because we cannot divide by 0. So this is a special case here. So we need to split this guy. Okay. All right. All right. Okay. Any question so far? Going too fast? Please ask. Okay. Please ask if you have question. Yeah. Don't be shy. You already paid for the course, so you should ask. Okay, next. Is this line statement important? Maybe I don't want to look at this line segment here. Okay, I will leave this. Let me know if you don't understand this. Okay. If you have any problem. Okay. Next. Show that the two lines here. Okay. So you are given two lines. So these are parametric equation. Okay, there are two lines. Show that these two lines are skewed lines. That is, they do not intersect and they are not parallel. Okay. So do not intersect means what? First of all, never reach each other. Okay. So that is the physical meaning. So how about on the solution set? How it demonstrate it? Yes, the solution when they equal is empty set. Okay. Right. It's empty. Oh yeah. Okay. Yeah. Okay. Okay. Good. Yeah. Right. So if you make L1 equals to L2, the solution set is empty. Okay. So this is they do not intersect. What else? So how about parallel? The two lines. The two lines never meet. Okay. Wait. Now we are living in 3D as well, right? We are living in 3D. Okay. So if in 3D, right, even though they never meet, they might not be parallel because this is 3D. Okay. I mean, in 2D, that is equivalent, but in 3D, it's not, right? Because you can imagine that these two lines doesn't intersect, but go to 3D, you can like go below it, but they are not parallel. Okay, but in 2D, I think those two formulations are equivalent, but 3D is not. Okay, so how to do is if it's not parallel. So parallel, okay. Wait. So wait. Hello. Wait, here. Okay, so so to see that they are parallel, you want something like this, even in 2D. Okay, so this means that their direction have to be the same. Okay, yeah, same direction vector. Okay, or any scalar multiple of them is fine. Okay, as long as you contain the same vector. Okay, so which one we want to do first? Parallel. Okay, let's do parallel first. So this one move down. Let's do parallel first. They are not parallel if their direction vectors are not scalar multiple of each other. Okay, so in the meantime, should find what's the direction vector for L1. What's the direction vector of L1? Can you straight away read from that parametric equation? 5, 3, -1. Okay, good. So this is exactly the coefficient of t, right? Okay, so you should remember that u plus tv. So the tv. So this v here is the direction vector plus the point passing through. Okay, so why we like algebra a lot? Because you can see that this line actually consists of
the point passing algebra, passing the, sorry, why would put algebra here? Passing the point in line, okay? So exactly this algebra here consists of the necessary information we need, okay? Precisely the vectors and the point, okay? So we like algebra a lot. So it seems like we turn geometry into algebra. So we just computing algebra. We don't need to go to the geometry and draw, okay? Okay, so next. So direction of L2 is what? 2, 1, and 4. Good. Okay. So whether this is a scalar multiple each other or not. So you can, if you like, you can use row reduction. Otherwise, you just use induct. I mean, I think I can't promote here. Okay, I will say use row reduction, or you can use algebra manipulation. Okay, row reduction meaning you can solve the whole system. Algebra manipulation is you use the, okay, maybe I use another word more familiar. Just use substitution. I use substitution, meaning equation by equation. Okay, so if I'm in another class, right, I will ask them to use inspection. Okay, what do you mean by inspection? So I just see that to satisfy the first equation, x have to be half. Okay, but if x is equal to half, it doesn't satisfy the second equation. Okay, so by inspection, you cannot find this x. But this is actually what you do for algebra substitution. Okay, for simple one, you can use inspection. X doesn't exist since no possible x. They are not scalar multiple of each other, which means they are not parallel. Okay, everyone follow? So the two, so L1, L2 are not parallel. Okay. Okay, so next, how about intercept? Just now we said that we want to make them meet. Okay, make them meet. So make them equal. So if L1, L2 intercept, which means there will be Tx such that equals to 2x minus 2 plus 3t equals to 3 plus x, 4 minus t equals to 3 plus 4x. Okay. You want to try and solve this, or let's see, right? Yeah, you can try and solve this. So there are how many variables? 2 variables here, but 3 equations. So this means this is like an overdetermined system. So you must be able to find solution. Okay, so this is an overdetermined solution system. Okay, so should we solve this? Try and solve this. Okay, let's quickly solve this. Otherwise, I think some of you won't believe. So maybe you can take 1 plus 3. Okay, and then we get 5 equals to 3 plus 6x. And then this would imply that x equals to 1/3. And then since you already found s equals to 1/3, then you can sub s equals to 1/3 back to 1.
okay, which you get t equals to 2 times 1 over 3 minus 1 equals to minus third. Okay, but we haven't touched 2 yet, right? Let us input everything back to 2. But minus 2 plus 3t is what? What is this? Negative 3. How about 3 plus x? Is 9, 10. 10 over 3. So they are not equal. Yeah, so contradiction. So this means that L1, L2 do not accept. Okay, so if you want to if you want to make system of linear equation, also can. Okay, also can. I mean row reduction. This is by, okay, let me write down this name here so that you know what I'm doing. So this is algebra substitution. You also can try, you could also try row reduction. So you need to set out the system first. Okay, find the augmented matrix and so on. It's good that you can practice both ways, then you know what's going on. I go relatively fast in calculating here. If you don't follow, doesn't mind. What I want you to get out is, if you cannot find solution to this system, they don't intersect. Okay, and then you can go back and take your free time and do this calculation and verify yourself. I know that this calculation might take some time. Understand? Sometimes it's quite painful, especially when you do those integral. But when you get the answer, you will be relieved. I promise. At least for me. Okay. All right. Before we left, we should continue one more. Oh shit! I pressed the wrong thing. Okay. So let's introduce one more equation before we left, which is the plane. So now we finished talking about line. Next, we talk about plane. Okay. How about plane? What information you need? What is the minimal information you need to define a plane? 3 point. 3 point. Okay, let's start. Let's experiment something. Okay, so let's experiment something. Okay, so hey, what's your name actually? What's your name? I want to know what you. Hong Ming. What's your? Hey, just realized I forget to pass down the attendance. Too excited. Hong Ming, what's your surname? How to spell? E-N-G, N-G-R. Okay. So your surname is yellow. Yellow. Not yellow. Your mom is bigger than your mom is bigger than my mouth. Yeah. Okay. Okay, I know. Okay, next. Okay. So talking about plane. Okay. So Hong Ming, right? Hong Ming. Okay, Hong Ming say you need 3 points. Okay. So maybe you need 3 points to build this triangle, is it? And then you extend it. Is this what you mean? Okay, this is a good idea. Okay. Why you say no? There's an objection. What do you mean? Oh, 3 points maybe all lie on the one line. But you can use 3 points to build a plane, right? If you take 3 points from the plane, then you can rebuild the plane. That's what I mean. Right? If you have a plane, you take 3 points, then you can rebuild this plane. Of course, this 3 line maybe is collinear, then you will get a line. Sure. Okay, but 3 points is enough for you to recover the plane. Right? Okay, this is what I mean. Okay.
Okay, but 3 point might be collinear. So any other idea? 2 points is enough. Or 2 intersection line. Okay, good. Okay, wow, we reduced to 2 line now. Okay, we just need 2 vectors. Okay. Wow, good. So minimal. So we from three data reduced to 2 data. Okay, any more? How? And what? Say again. Then how you draw the plane? Can. How? Okay, a line and a point. How to form a what's that? What's that? So a point and a line, how to form a plane? 2 points from the line. Another 3 points is too many already, huh? You mean take 2 points from the line and then form the plane. Where's the plane? Next. And then the 3 points. Okay. Then this has no point, right? Then I don't need this anymore. Okay, we just take these 3 points enough, right? So, okay, there's another more minimal point, more minimal method is you can pick the normal vector from these 2 lines, okay, and then you just pick 1 point on this plane. Okay, then we can form the plane. Okay, a point with a vector, we also can form a plane. Okay, so how? So let's see how. So the equation of plane that passing through a point x naught, y naught, z naught, and perpendicular to the vector ABC is just a times shifted x by that point s0, and then b times y minus y0 plus c times z minus z0. Okay. So are you interested in the derivation or not? No. Actually, it's very short. You can read from the book. I also will include in the note. You can read. It's quite short. Right now. Okay, sure. We don't have time. We can derive and then we break. Yeah. Okay. So we derive and then we break. Okay. So this is quite short. Okay. So this derivation is very short. So let's see. Okay. So this is a shifted plane here. Okay. You can see that every time you see x minus something, right? Most probably this is a shifted stuff. Okay. So you can see that this is shifted away from the origin. Okay. So the idea is this normal vector, right, should be perpendicular to some vector inside, line inside here. Okay. So in particular, we can find a vector. All the vector inside here is actually perpendicular to this vector. Okay. But there's one obvious vector you can take, okay, from these 2 points here, from this x0, y0, z0. So you need a plane that passes through this point. Okay, first of all, your plane contains this point, and then all the other point is called SYZ. Okay, and then these points, right? The vector from S0, Y0 to Z0, Z0 to all these points, the vector should all be perpendicular to N. Okay, this is the condition we use. So let me write down the equation here. So the normal vector should be perpendicular to all the vector. Let's call it x. Okay, x. Okay. I don't want to call it x, so maybe call it z. Right. Call it omega. Okay, omega. So what's this omega here? This omega is actually the difference between all other point and the fixed point we have. Okay, we call all other point as SR hat. Okay, these are all the other points. Okay, so if any point satisfy this condition here, all the R here, we take it as our plane. Okay, so then turning into algebraic property is n dot r hat minus r naught is 0. Okay, so what is n? N is ABC in this case, right? Yeah, we are given n is ABC, so n equals to ABC. Okay, what is R naught? What is R? R is any point that satisfy this equation. And then R naught is the point that we want to pass through. Alarm, time's up. Okay, finish, last two lines. Okay, and then you can do the algebra manipulation you like. So you just take the difference. X minus S naught, Y minus Y naught, Z minus Z naught. Okay, and then you should see the result. The inner product is first column times the first component, and then second component plus second component plus multiply second component, and then yeah. So one key point here. So when you see this line, this equation, right, you should think of it as the inner product between the normal vector with the point inside your plane. Okay, that's why you got this plus 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 or this plus, and then you got this multiplication. So you should think of it as a inner product between the normal vector with the point inside your plane. Okay, that's all. Okay, see you next next week. Yeah, next week. Please bring the attendance list to the front, and then whoever haven't signed, please sign here. Please don't lose my. Please bring the attendance list to the front here, and then whoever haven't signed it, come to the front and sign. Where's the attendance list now? Yeah. Or everyone can go there as well. Cannot. Okay, bring here. Quick. Bring here. They need to leave. Not here. Wait. Okay, wait. Let me stop the recording.